clock has one of these raising edges. So we have 4 possible combinations: 0, 0, 0, 1, 1, 0, and 1, 1. And the behavior of this circuit is such that when S and R are 0 and the clock makes one of these transitions, then Q will remain exactly as the value that it had before. In other words, when S and R are 0, the clock transition creates no transition in the output. The output maintain, or both outputs maintain their values. However, when we have a 0-1 combination and a clock transition comes, then the output of the circuit becomes 0. In other words, when I have a 0-1 combination here and the clock ticks and the clock makes this transition, then this value will become 0 and this value will become 1. This combination 1, 0 will make a transition such that Q at t plus 1 will become 1, and this latch or flip-flop has a very interesting property, which is when both inputs are 1, the output at the next time cannot be predicted. In other words, basically this case should be avoided. Okay, so after looking at this, we're going to see 2 more types of flip-flops which are similar. The first one is the JK flip-flop, which has again 3 inputs, J, K, and clock, and the same 2 outputs as before, Q and Q bar. So this flip-flop over here behaves very similar to this one with a slight difference. And this is represented by the transition table. We specify the values of J and K at time t, and we calculate the value of Q at time t plus 1. As in the previous case, we have 4 possible combinations: 0, 0, 0, 1, 1, 0, 1, 1. And the JK flip-flop behaves similar to the SR flip-flop, except that in this 4th transition over here, whenever both signals are 1, 1, the flip-flop, rather to be unstable, like in this case, what it does is it changes the value of its output.